Hello, so let's start. We're going to talk about package managers, and I hope that's what you're here for. If not, there's a door on each side. This is actually not a cathedral, this is a church. It's La Sagrada Familia in Barcelona, which has been under construction for over 100 years, and they plan to finish this by 2026, roughly. That's the plan today. Now, before we start, two questions for you. How many of you use a distro package manager on Linux? Pretty much everyone. How many of you use a language-specific package manager like NPM, PyPy, Ruby Gems? Okay. And how many of you rely on the distro package manager to provision your language-specific packages? It's much fewer, which is what I was expecting. So some do, but most of them do not. And that's a bit the topic of the talk. So a bit about me. My mission, and that's what I do in and out of work, is to make it easier to reuse free, library, and open source software. I'm a developer and maintainer of several packages, a series of projects called About Code. That's my primary set, including something called Scan Code, which is a tool for scanning for license, packages, and origins. I contribute to the Linux kernel, a bit on strace, and many other projects. So, the question, that thing that bothers me is, why each time, so I run Linux on all my machines, why each time I run apt install, apt upgrade, things works 99.999% of the time, mostly. And that applies to Debian-based distros or RPM-based distros. And why, when I do a pip and npm, a bundle install, things don't work? Much more often than 9 nines, right? And you're laughing, so obviously that probably resonates a bit. It's things don't always work, they don't often work. They very often don't work at all. And it bothers me because I was actually bitching against distro developers and says, why don't they get the latest version of the packages I want? And why do I have to not use the distro manager which works and use another package manager that doesn't work but gets the stuff that I want? Right? That's the problem. So why did I call this talk Cathedral, talking about Cathedral, the Cathedral and Bazaar? I don't know if any of you were born last century. I'm an old dog. But last century there was somebody called Eric Kremen, family name called ESR, that wrote a seminal essay called The Cathedral and the Bazaar. And this is not exactly the same cathedral and bazaars we're talking about today. But his point was, how come that a development process as messy as the development of Linux, where patches are coming from every places, ends up being able to build a system that works, and that works pretty darn well most of the time. And one of the things that things were released very often, on the one hand, a lot of betas, and everything was delegated, whereas his point was that another style of development is more of the cathedral approach, where you architect things nicely and you're a bit less open about accepting contributions. Now, that's just a side note, but I reuse this because it resonates in the world of package management. There's really two types of packages: package cathedrals, and that's the one for distros, and the bazaars. That's the one for language-specific packages. So the one we use for Rust, Node, Python, Ruby, and the likes. And they're really not at all the same packages. They're very, very different. And we call them all packages, but that's probably a misnomer. A distro package works typically for a single operating system, right? You're building for Fedora, Debian, and so on. You don't have to worry much about your code running on Mac and Windows most of the time. That may be a concern of a language-specific package, whether it's built in C or C++ or in an OS-agnostic language that requires some native dependencies. The package management systems are general purpose for distros and very specific for, and very specific when it comes to language. And as I heard before, okay, Conan is a C++ package manager. Can you build Node Java package with it? Possibly. And you can probably do that, put JavaScript in PyPy and Java in NPMs. But it's usually a lot of hacking and tweaking that's required there. It's not their primary purpose. The other thing is that if you think about a package, if you're a library author or consumer, it's really about authors and individuals. There's one or a group of person that provides a bit of code that's supposed to be very specific in terms of function. In the context of distros, we have usually a team of maintainers which work collaboratively together to not package one, but package many packages that are related and of the same family. There's another context also. You're either a user or a builder, which differs. The testing is interesting. How many of you do know a project called Apache Gump? Okay, it's a pretty obscure project. It's actually interesting and weird. They're taking all the head of every project at Apache and try to build them all the time with the latest head. So each time there's a commit, they rebuild everything against the latest and greatest. Obviously, it's very often read and doesn't build. But what's interesting to understand is that when you build a distro, you don't care about having just the test of one package, but you want to make sure that all your packages for a given version release work with the same version of libc and the same version of this and that. And you release them together. You don't release just one. Sometimes you release one, but if it's usually a .version, it's going to be always in the context of a larger whole and a main distro release. The other thing on the dependency side, the dependencies we express most of the time for language-specific packages are pretty simple, whereas the dependency language for distro packages are actually pretty rich. There's a lot of things which you look at them, says conflict, depends, resolve, obsoletes. There's a very different context of managing dependencies. The other thing also, and most of the time when we consume package from a language repository, we do consume these as is. You take a Maven jar, verbatim. You take an NPM, 99% of the time you release it as is. The packages that are provided by distros, in contrast, are 99% of the time patched, modified, deconstructed, reconstructed. You take a spell, which is a spell checker, one nice tarball of stream. In distro, it ends up being possibly 50 packages. One for each language, for the dictionaries, maybe one for the library, one for a command line tool. So we are not talking at all about the same packages. Now, if you take the builder perspective, the bazaar is like a box of Legos. And the cathedral is trying to build an actual thing with these Legos. So now, thinking again about your perspective, as a user, even if I'm a developer, so forget you're developing software for a minute. As a user, you want a system that's stable, that works, that installs and updates all the time, right? That's what you get from a distro. As a builder, I want the Lego bricks that I can build my cathedral with. And I don't care too much about the rest. I want to make sure they're really fit for their function, they have a single well-known purpose, and I can use them as a brick, as a stone, and assemble my edifice. So now, let's dive a bit again into dependencies. Most language-specific package managers, I say most, there's always variants, have usually two options, maybe three. options on how you express dependencies and how and when dependent packages are used. It's usually build, setup, time, or runtime. And that's pretty much it. And it works actually quite well. You rarely need much more than that. Some package manager, I think it's PHP Composer, expose kind of distro-like, more richer language with a lot of verbs and type of dependencies. I'm not sure they're very much used, but it's more of an exception. The other thing is that in most cases, language-specific package managers have a fairly simple way to resolve dependency conflicts. So dependency conflict is when in your dependency tree, two packages require the same package with a version that don't match. NPM, for instance, has a sleek way to resolve that by saying, I don't care, I'll take all the versions, which can be a problem. I'm sure you face that at times. In contrast, distro package have evolved to have fairly complicated and complex way to resolve dependency using what's called a SAT solver and Boolean satisfiability, which is really something that's very simple at the basis, but extremely complex in terms of its implementation. It's eventually an NP-hard problem. And to the best of my knowledge, there's very few, if any, language package managers that have or that use any SAT solver-based dependency resolution. One of them, I think, is Conda in the Python scientific world. But it's quasi-distro-like package manager rather than being very language-specific. There's no such thing in Bundler, NPM, or pip, for instance. The other thing that makes a big difference is the kind of social contract that exists between the language-specific package management environment and the distro package management environment. Again, in the language-specific world, it's usually individuals. When I say individuals, that can be a team, but you're usually producing one brick, one Lego brick at a time. You focus as much as possible on a single function. There's no coordination that's required most of the time with other package managers. You just consume their stuff. You don't care what they do. You don't care about their testing and the whole stuff. You just care about eventually, in the confine of your single project, are my dependencies and direct dependency resolved and working, but you don't care about the rest. And it's a bit having a utilitarian look at things. If you think about plastic bricks, Legos, you care about the mold, injection molding, the quality of plastic you take. In contrast, when you're building a distro, it's more like art and architecture. You go to the bazaar and you pick the bricks, the Legos. You want to make sure you know their characteristics in terms of plastics and else. But there's a really extensive effort for collaboration and coordination. And in fact, at some level, there's little code that's produced, reasonably speaking, and relatively speaking to the rest of the scope, and a lot of discussions. So that's really a very important distinction. Now, let's turn the things a bit around. In fact, you could think probably as each package that you write as a library or an individual project as a mini cathedral of its own. You care about testing. You care about ensuring that your code works in the context of its dependencies and that doesn't crash all the time. And think of it as if you were taking these small cathedrals and assembling them further up. So it's really eventually not really strict separation between one and the two, but it's turtles all the way down. And that's what makes eventually things work. So there's a way to eventually reconcile that at some level. So what happens today really is that there's really these two contexts. Either I'm a user or a builder. and I'm usually both at the same time. I am building components and package for them to be reused, and I'm reusing mine and further package to build system and applications. And that's building of system of an application is a system integration job. That's what Linux distro do. What's thing that's often overlooked is when you start using, for instance, containers, you very quickly actually are becoming your own system integrator. You escape the confine of the nice assembly and coordination work that's done by distro maintainers, and you take the responsibility without really knowing it. Each container ends up being eventually as complex and as messy as a whole Linux distribution, but usually there's not the same discipline and efforts of coordination and collaboration that's been put into it, so that's important. And so I will stop bitching, and I think we all should stop bitching about out-of-date distro packages. We should work with distros to help them in many ways. One, if we want to make sure that our latest language runtime or package manager is available, well, we can help. You don't have to be the maintainer of the packaging tools to help on maintaining that package proper. And actually, weirdly enough, there are very few upstream package authors that are effectively the maintainer of their own package in distros. Because there's one upstream authors and many, many distros eventually. So you can help this way. And the other way you can help is when you're building packages, and I'm terribly bad at that, make sure that they're actually easy to package upstream by distros. And possibly you can provide a package manifest for your favorite distros, whether it would be Brew on a Mac or a Debian or RPM package, which can help the work upstream. And you can collaborate the work downstream. And you can collaborate with the package manager and distro to make your package easier and faster to package. And so really, I think that's important. It's often overlooked. Distros don't happen by accident. It's a lot of hard work and coordination that's needed, and we all need to give a bit of love there. And that's it. Just a plug, I'll be doing a talk on tracing build with a trace in another computing room, and I'll be back after that in this room here. Thank you. Any question?
What's your point of view about repackaging in the distributions, the specifics of package, like in computer, you have a lot, or NPM, you have a lot of package, and really a lot, and it is really hard to maintain because some languages don't care about simplicity and expand. So, what's your point of view about the packaging, solving those problems in distributions?
That's a complex topic. So the question is, what about the repackaging of language-specific packages in distributions?
Yeah, with the size, the number.
And especially the number of packages that may exist, which are typically in the tens or hundreds of thousands in an upstream, in a language-specific package repository environment. It's a difficult thing. On the one hand, distros, being software, often have direct dependencies on a specific package and package version. Take the case for RPM-based distros. For a long time, they depended on Python 2.4 and then Python 2.6, even though it was a long time since Python 2.7, Python 3 were available. So they have this need of dependencies of their own to actually run on the one hand. And on the other hand, they want also to provide some level of coverage for language-specific packages. I don't have an answer. I don't know what's to be done there. The reality is that most of the language-specific packages are often considered outdated when they're in the distro, even in the latest release of a distro. And folks tend to not do system-wide installation, but always project-specific or user-specific installation. There's probably, I don't think there's a really easy solution. One would be to repackage everything, but that's like double packaging. Probably may make sense to instead work with distros to ensure, for instance, if you work with Node, that you have the latest Node runtime and NPM installed. Same thing for Ruby and Python. And probably let go at a distro level of language-specific package repackaging, unless you have a direct dependency and a need for system-wide installation for it. That probably would be the best bet. That probably would simplify the work too. The difficult.
You can't let go at the distribution level, because the distribution includes applications, and lots of applications need those.
Yeah, so it's not an easy. There's no easy solution, unfortunately.
And do you think that container images could help, because there is maybe a clear contract between the distro and the project, the applicative project that you put in your image, and then it's more easy to deploy and package your project using Docker images or container images instead of using classic package manager?
Yeah. So the question is do containers and Docker provide a solution to the problem of distro versus language packages? I don't think so. They actually amplify the problem at some level. What is a container? It's essentially a slice of, or it's a mini distro. It's a slice of user land. So you have everything but a kernel, but you have everything. What it provides is isolation, and what you give up for isolation is immutability. So your container is immutable. It's not easy to update. Eventually you need to rebuild it, otherwise you're just accumulating levels over levels of updates. The thing is that you have one benefit, which is you can trim down the set of dependencies to just what you need. So that's a good thing. You can isolate them. That's also a good thing, but there's very simple ways to do that, just using user level installations. It's supposed to help with deployments on a massive scale, so that has benefits. It's much simpler to deploy a single file on many machines than a lot of packages. The fact it's immutable, it's a good thing in some case. It's also a pain when you have a security bug and you've deployed 200 containers, each with small variations. You have to rebuild 200 containers. It's not fun. So I'm not sure it's really solving any of the problems there. It helps in some case. It creates a lot of other issues in the other end. The other thing, talking about containers, is that when you actually redistribute containers or deploy containers, you are de facto your whole stack Linux integrator. You took responsibility for the whole stack above the kernel, and there's much more ceremony that's needed there in terms of compliance on the license, bug tracking, security tracking, things that were provided to you as a service by distros that you may no longer benefit of all the time. Yes?
Yeah, I just want to know your opinion about is this differentiation between cathedrals and bazaars something due to the design fashions of the previous generation of generating distributions, and now we are going to more agnostic languages that are just everywhere and can run everywhere, and then new designers start designing package management in a different way completely?
So the question is this dichotomy between bazaar and cathedral something of the past, or will there be something that's more language agnostic?
Because for me, Docker, for example, seems like a bazaar of cathedrals.
Yes.
But it's like
It's not a cathedral of bazaars, it's the opposite. That's kind of true.
Well, but it's like a modern solution to something really, really old like distributions. Is something, is age a factor?
So the difficulty there is it's hard to build package managers, and actually there are talks today. It's really hard. I've tried a few bits of time and I failed lamentably every time. So it's a difficult job. I've built distros, not Linux distros, but long time ago an Eclipse-based distribution which was called Easy Eclipse, and which had at a very small scale all the problems of that you can have in a Linux distribution. It's again the problem between the bazaar and not the bazaar. It's not so much a technical issue. It's more a problem of coordination, and this coordination, there's no tool that can actually fulfill it. You have to have people that discuss, and if you see all the efforts that's deployed by distribution teams to have package trackers and ways that they can collaborate and track all the things, that's where the big effort is. Now, there's maybe a bit of light on the horizon. There are kind of two emerging things on the distro side. One is Nix, and on the package management side, one is SPAC, and which provides kind of very different take on the whole problem. Go ahead.
Oh, so I was just.
He's the maintainer of SPAC, by the way.
So you said that we should give the distros some love. I guess my question would be, what can the distros do for the packagers, and what can the packagers do for the distros to grease the skin? Because, I mean, if you think about what a distro is, it's all the glue that was required, given a certain set of base assumptions, to build all these packages on top, right? So what do you do to automate the glue?
Yeah, well, that's the problem. You can't. The glue, eventually, when everything is a package, the glue is what you and I do to actually take a bunch of Lego bricks and make it a system. Okay, so time's up. We can take the discussion offline or later. I'm sorry. Thank you very much.
What was the two alternatives you mentioned?
Nix, which is a Linux distribution.
Nix, like this.
Nix.
Okay.
And SPAC, S-P-A-C-K.
It's fine. Okay.